Most mass market SAT prep companies literally teach students to skip questions. In other words, they teach students to recognize the types of questions that students should never answer on an SAT. And the idea is that those questions are supposed to be either too hard or too complicated for students to reliably be able to solve, so you're better off not even trying. You're better off giving up before you even start. So after taking the tuition money, they literally sit you down and they teach you to not answer questions. Obviously, I think that's ridiculous, and in today's video, I'm going to show you how to answer specific questions that other companies, other mass market companies have told students of mine to skip, and I'm going to show you how those questions can be solved using a few simple steps of algebra. In this video, I'm only going to talk about math, but the same applies to reading and grammar. In fact, there is no reason, if you have the right kind of training, that you will ever need to skip an SAT question. The questions we're going to be looking at are out of the official SAT study guide, and the first question we're looking at is page 919, number 16. This specific question, many companies have told many students of mine to skip, and I'm going to show you just how simple it is to do this problem using regular basic algebra. The question says this: if xy equals 7 and x minus y equals 5, then find x squared y minus xy squared. Now, in order to understand this, here's what you would do in school. If you're going to do this in school, you might do it like this. You would say that, x equals, adding y to both sides, x equals 5 plus y, and then you plug that back in, you get 5 plus y times y equals 7. And this eventually will work. You'll have to solve a quadratic equation. It'll be unpleasant, but it'll eventually work. But that's not the best way to do this. The best way to do this is to look at the question being asked and recognize they're not asking you to solve for x or for y, but to solve for this entire mathematical expression. And what you need to do is notice that this times this equals this. In other words, if you factor this, you're going to get xy times x minus y is the same thing as this. Xy equals 7, x minus y equals 5. We know that from right here. So it's just 7 times 5, which is 35. And we can do this essentially in 1, 2, 3 steps. 4 steps if you want to include writing down the problem. This is a super easy problem to do as long as you apply algebra in a systematic and standard fashion. You don't need to use plug-in or back-solve or any of the other silly gimmicks that many of the SAT companies nowadays teach. The next problem we're going to do, this next technique, is a little bit more advanced, and it's not the first question you would do. If you were doing this in a Vohra method seminar, you would actually do several other questions leading up to this question, kind of building up your skills, just getting used to using some of these number line oriented techniques. This is a very standard thing to do in abstract math or in advanced math. It's a little bit less common to use this specific technique in high school level math, but it's not that difficult to do at this level. And what I'm going to show you right now is how you would apply these more advanced techniques to this problem. And obviously, I'm just going to do it as a demonstration. The question says if n and p are integers greater than 1, and if p is a factor of both n plus 3 and n plus 10, what is the value of p? So let's think about what that means. P is a factor of n plus 3 and n plus 10. That means that both n plus 3 and n plus 10 are multiples of p. What does that mean? That means that, let's think about multiples of, for example, 6. If you have the multiples of 6, you have 6, 12, 18, 24. Look at how far apart they are. They're 6 units apart. Same thing for multiples of 5. Multiples of 5 are 5 units apart. Now n plus 3 and n plus 10 are both multiples of something, and we need to find out what that something is. So what we do is we draw a number line, we put n plus 3 here, and then we put n plus 10 here. And we say, let's decide how far apart these two numbers are. And they're obviously 7 apart. Now you can actually count that out, 4, 5, 6, 7, 8, 9, 10, or you can just subtract. But the point is that they're 7 units apart. And if multiples of some specific number are 7 units apart, that means they both must be multiples of 7. Again, this technique is a little bit more advanced. This is not something that you would have seen in your algebra classes or your pre-cal classes, but it's a very learnable technique. 100% of my students are able to learn how to do this technique. And while it's a little bit unfamiliar at first, with the right kind of training, the right system, you're going to be able to master this type of a technique and use it on a whole slew of different type of SAT problems. I can't even begin to tell you how many of my students have told me that their SAT class or SAT tutor has told them that if they see a problem like this, just to skip it. They've told, it's an almost limitless number of my students have been told to skip this specific problem. And I'm going to show you just how systematically you can solve it using the type of techniques you learn in a Vohra method seminar or Vohra method tutoring. Here's what it says. If a and b are positive integers and a to the 1/2 times b to the 1/3, the whole thing to the 6th equals 432, what is the value of ab? This is, again, an advanced technique. And this would not be the first question you would do if you were doing this in a Vohra method seminar. You would have several questions that would build you up to this. I'm just going to show you as a demonstration how you would learn to do a question like this in a Vohra method style seminar. Let's go ahead and write the problem. It says a to the 1/2 times, by the way, this is page 714, number 8. So a to the 1/2 times b to the 1/3, that whole thing to the 6th, equals 432. Now, if you're not comfortable with fractional exponents and the laws of exponents, obviously in a Vohra method seminar you would build those skills first. But I'm just going to go ahead and just do the left side of this equation, simplify it a little bit. And basically when you distribute the, essentially, it's kind of like distributing the 6. What you get is you get a to the 3rd times b squared equals 432. That's the first step. Now, at this point, it just seems almost, what do you want to do? Do you take the cube root or the square root? You actually don't do either one. Right now, we're going to go all the way back to like 4th grade, and we're going to do a factor tree. We're going to do the prime factorization of 432. So let's go ahead and do that. We know that's 2 times 216, which is 2 times 108, and that's 2 times 54, and that's 2 times 27, and that's 3 times 9, which is 3 times 3. So this equals 432 equals 2 to the 1, 2, 3, 4 to the 4 times 3 to the 1, 2, 3 times 3 to the 3rd. So we get a to the 3rd times b squared equals 2 to the 4 times 3 to the 3rd. What do we notice over here? We notice that in this sort of broken down form, a is being raised to the 3rd and 3 is being raised to the 3rd. So we can realize that a, by pretty standard observation, equals 3. In a class, you might do it a little bit more rigorously, but that, you can basically see that it equals 3, which leaves us that with the statement that b squared equals 2 to the 4. 2 to the 4 is 16, so you have b squared equals 16, or that b equals 4. And the question says, what is ab? That means ab equals 3 times 4, or that it equals 12. Again, this technique is a little bit more advanced. It might be unfamiliar to many of you, but in a Vohra method seminar, you would gradually build up to this. So you wouldn't just start with this problem. You'd build up to this problem until you were completely comfortable. If you happen to feel that this is a very easy problem, you could just start with this problem and work up from here. It's one of the huge advantages of the Vohra method is that we adjust the material immediately to your level, so you're being challenged, but you're not being overwhelmed. Many, many, many of my students have been told to give up on this problem or to just not try this problem by their SAT tutors, their SAT classes. And when they see a problem like this, again, they've been told that they should skip all problems like this. Now, this is a legitimately hard problem, and I'm going to show you how you can use the real mathematical techniques that you would learn in a Vohra method class to solve this type of a problem. Okay, there's a picture. I'm going to redraw it bigger. Don't worry about that. It says, in the figure above, arc SBT is 1/4 of a circle with center R and radius 6. If the length plus the width of rectangle ABCR is 8, then the perimeter of the shaded region is, well, one of these. This, by the way, is page 852. It's problem number 20. So let's go ahead and redraw this. So we have a quarter circle. And then inside of that circle, we have this rectangle, and this is R, R, C, T, B, and this is S, and that is A. And this is line AC. And we need to find the perimeter of this thing over here. So there's going to be several parts of it. Some of the parts are going to be pretty easy. Some parts are going to be more difficult. The first thing we want to do is we want to find the length of arc SBT. That's not too hard to do because it's a fourth of a circle, and the radius of this circle is 6. So we know if the radius equals 6, then the circumference equals 2 times pi times 6, which equals 12 pi, and that 1/4 of that of 12 pi equals 3 pi. So that part's fairly straightforward. The next part of this is we want to figure out what is the length of AC. Now that's hard to do. The mistaken way that most people do this, or that most people try to do it incorrectly, is they just kind of use the wishful thinking method where we know that the whole length RT is 6, when we just kind of hope that CT is somewhere in the middle, so we decide that this is 3, and that this is 5, and that this is root 34. That is just simply wrong. I mean, that's just not true at all. That'll just get you the wrong answer. Here's what you need to do. Normally if you have a diagonal line, you'll use the Pythagorean theorem. Not this time. In this case, what you do is you're going to recognize that AC and RB are both the same length, because they're both diagonals of this rectangle. Also, RB is a radius of the circle. See how it goes from the center to the edge of the circle? It means it's a radius of the circle. That means we know that RB is the radius, so it's 6. And that's the same thing as AC, so AC is also 6. So we have that this piece over here, AC, equals 6. Now the last part of this is complex, because we now need to find SA and we need to find CT. Now, many people want to try to find them separately by find SA first and then CT. That actually can't really be done. I mean, not that it can't be done, it's just unnecessarily difficult to do. Instead, we're going to find them together as a unit. We're going to find them together, and here's how we're going to do it. You have to look at the wording of the question. One of the things that they say is that the length plus the width of this rectangle, that this L shape over here, is 8. That's a strange bit of information to give, and it's definitely a hint. If they say something weird on the SAT, you're being given a hint. So this distance over here is 8, and we know that this whole distance from SR to T, this huge distance here, is 6 plus 6, which is 12, right? So the big distance is 12, this little L is 8, that means this plus this equals 4. And so the total is going to be 6 plus 4 plus 3 pi, or 10 plus 3 pi. Now, obviously, if you're in a Vohra method class, or Vohra method tutoring, or seminar, or whatever, Obviously, this is not going to be the first question you do. You will most definitely build up to this question. You'll be given, walkthroughs. This is a very advanced problem, but notice that it's something that with the right kind of training, you will be able to solve these questions reliably, systematically, using algebra and basic rules of geometry, not using process of elimination and guesswork and all that kind of silly stuff. The next question that we're going to do is page 598, number 18. And students of mine have had two experiences. Some students have said that their other classes or their tutors have told them to skip this question. Others have actually just shown methods to solve this question that are so roundabout and ridiculous that I really felt that this specific question really deserved to be demonstrated. Oh, here's what it says. It says, if the 5 cards shown above are placed in a row so that this solid colored one is never at either end, how many different arrangements are possible? And this uses a method called combinatorics, and I'm just going to do this as a demonstration because, again, this would be something that you would do in a Vohra method class after you'd kind of built up several other problems to get to this one. But here's how you would eventually learn how to do this in a Vohra method class. First, we're going to make 5 blanks that represent the 5 positions, and we're going to put multiplication signs in between them. And we're basically going to decide how many choices you have for each position. We're going to do the first position first because it has restrictions on it. The restriction is that you can't put the solid colored one here. So you can put anything here you want to except for the solid colored one, so you have 4 choices. Now the other restricted position is this one, the last one, because you can't put the solid colored one, the last one either. So how many choices are left? Well, you put one down here already, and now you can't put the solid colored one here, so you only have 3 choices. Now we're going to do the rest of these, which have no real restrictions on them. This one you have 3 choices. Why? Because you've already put down 2 cards. There's 5 total cards, so only you have 3 left after you put 2 of them down. Then you have 2 choices here because there are only 2 cards left, and there's 1 card left over here. And then you just need to multiply it out. It's a super simple technique. 4 times 3 is 12, times 2 is 24, and times 1 is 24 again, and then times 3 is 72. And again, if you learn this technique of combinatorics, it makes these how many arrangements are possible questions just super easy to do. You'll get 100% of them right because this is one of those things where you just learn the technique. You can do really any question that of any level of difficulty that you're going to see on the SAT. And this is part of every single Vohra method math training program, whether it's the Vohra method seminars, whether you're live via Skype or doing one-on-one tutoring, doesn't matter. This technique is just super efficient and it's super valuable, and you are guaranteed to learn it if you are involved in a Vohra method program. The next problem we're looking at is page 595, number 8. This is a problem that some other SAT tutors have taught students to do, but the experience that I've had is they've actually taught them to do it in a really just roundabout, unnecessarily difficult way that involves a whole bunch of just kind of silly and superfluous techniques. And I'm going to show you how this problem can be done very, very easily. I'm going to just redraw it. It says in the figure above, what is the value of C in terms of A and B? I'm going to draw a bigger picture so we can look at it, and here's basically what the picture looks like. Oops. And then it has this little triangle inside of it. And it says that this is B, C, A, this is B degrees, B, and also A degrees. And so we need to find C in terms of the rest of these. Now this diagram is deliberately designed to mislead you because it wants you to think about triangles because it has this huge triangle here, the big triangle and the little triangle and all these other triangles. But that's not actually the best way to look at this problem. The best way to do this problem is to realize that over here we have, guess what? We have a quadrilateral. It kind of looks a little bit like a trapezoid, but there's no reason to think that it is. But it is definitely a quadrilateral. It has 4 sides. And what do we know about quadrilaterals? We know that the angles of a quadrilateral add up to 360. In other words, A plus, now this is B plus B, right? Or just 2B. plus, this is C plus A, or just C plus A, I mean A plus C, plus B equals 360. Now the first thing we obviously need to do is we need to combine like terms. Have two A's over here, we get 2A plus 2B and one more B plus 3B plus C equals 360. And we just need to solve for C. See, it's super easy at this point. We just subtract 3B from both sides. Minus 3B minus 2A and minus 2A, and we get that C equals 360 minus 3B minus 2A. Again, the subtlety of this problem is you have to notice that you're dealing with a quadrilateral, and that makes it a 2 or 3 step geometry problem instead of like a 15-step mess by using the triangles, or just like a 50 or 100-step problem if you try to do this with plug-in or something silly like that. So again, super simple problem as long as you recognize the subtlety that you're dealing with. And that's going to be a part of any Vohra method program, is going to be learning to pick up on these type of subtleties so you can solve these problems in 2 or 3 efficient steps, not in 10 or 50 or 100 inefficient steps. No matter where you are in the world, you can access Vohra method SAT training via Skype and Google Docs. We guarantee that your score will either improve by 450 points, be above 2250, or you get an additional 6 months of training for free, and you can come to as many Vohra method classes as you would like during that time period. And if that doesn't work, you know what? You get an additional 6 months after that, because just like I teach you to not skip a single problem, we never give up on any student. We will, no matter what it takes, no matter how many times you have to go through this, we'll make sure that your score improves, and like that's a fact right over there. Now, to find out more information, visit our website. That's arvinvohra.com, or you can call directly 301-320-3634. No matter where you are on the planet, you can learn how to solve the problems that other companies will tell you to skip.